Right, so really big video. And really, I think more or less the only real video you need to just understand how surds work. And then after that, as you remember in what I said in the last video, questions with surds just work like normal algebra. You're going to see this. But this video, this is where surds are slightly different from algebra. And you'll see it's really not that big a deal. So, despite what some of you are taught, and even what's said in the revision guide, there are only actually 2 rules for surds you need to know. Any of the other rules which they tell you anywhere else is just the exact same way which algebra works. Again, you don't need to understand what I mean by that right now. You will see what I mean as I go through it. But here, only 2 rules you need to know, and really 1 rule which you have to remember not to fall into the trap of. That's going to be number 3 over here. So the first one, let's go into that. It's just saying, look, square root of a times square root of b. So imagine you've got 2 different surds multiplying together. So let's just pick square root of 3 times square root of 5. Then that says that whatever the answer to this is going to be the same as if I had 1 surd where the number inside was just these 2 multiplied together. In other words, square root of 15. And again, check this. So, do the square root of, in the calculator, do the square root of 3 times square root of 15. Now, what am I talking about? Square root of 3 times square root of 5. So if I do this in the calculator, this gives me 3.87298. Now, do the square root of 15. Exactly the same. That's all this rule is saying. It's not this magical thing which you have to remember is correct. There's no other way of figuring it out. Yes, it's got a reason basically. And here's the deal. If you ever forget, here's one way you can test. You know what the square root of 4 is, and you know what the square root of 9 is. Square root of 4 is 2, square root of 9 is 3. So imagine you're doing this. So you're like square root. So you've basically forgotten, if I square root 2 numbers, is it you're like, do I, what am I trying to say? Yeah. If I'm trying to multiply 2 square roots, I think it just becomes 1 surd where the 2 numbers are the same numbers multiplied together. Quite a mouthful, we got there. So here's how you test it. So you're like, I know this is 2, I know this is 3, so I know that obviously that equals 6, yeah? I know that whatever the answer to this is also going to have to equal 6. So say if I'm like, is it 4 times 9? Does that mean if I join 2 square roots together, I just multiply the numbers? Well, here's what's 4 times 9? That will give you square root of 36. What is the square root of 36? It's also 6. So yeah, it is a case of 1 square root times the other gives you the other 2 squared times together, you know what I mean. So that's the first rule. And by the way, so now you want to get very comfy with this stuff. So if I gave you square root of 2 times square root of 14, what do you think that is? It's literally just 1 square root where you multiply the separate square root numbers together. This is the exact same as square root of 28. Do it in your calculator. Do square root of 2 times square root of 14. See what number that gives you. And then do the square root of 28. It should be exactly the same. If it's not, I don't know, you typed something wrong. Again, so, as I write this, I want you to almost like shout out loud in your head what the answer to this is. Yeah, square root of 30. 3 times 10. Square root of 5 times square root of, it doesn't really matter, 11? What do you think that is? Square root of 55. Okay? That's it. That's literally it. Now, the other thing to also understand is that if I give you square root of 20, obviously there's quite a few different ways I can break this down. So I can make 20 by saying like 4 times 5. So can you see square root of 4 times square root of 5 would have to be the same as that? I also broke it down in a different way. So can you see that would also have to be the same as that? Check it. Check it. This is the same as that, and both of those are the same as that. Now, that's a very important thing, because you're gonna need to be very comfy breaking big surds down to small. And all that is you know how I showed you how we can go from, if I gave you two surds, you can make it into one. You also need to be comfortable going the other way. If I give you a bigger surd, which, you know, the number inside is just basically two smaller numbers multiplying, well, then you need to be comfy breaking that up. I'll go to that in a second, but let's run through the other rule as well. So that's literally what the first rule is. There's nothing more to that than that. So the second rule is really similar. Whereas this one said if I've got two surds multiplying together, I get, you know, one surd with the two numbers inside multiplying. This one just says if I've got one surd that's divided by the other, guess what? I can just do one big surd with the top numbers divided by the bottom. So here's go. Let's do this. So say I gave you square root of 10 over square root of 2. Now first, just put that into the calculator. Square root of 10 divided by square root of 2. That's 2.236 and so on, yeah? Well, using this rule, it says one surd divided by another one. That should give you just one surd. You can join that together to just give you one surd, where the inside is just that number divided by that number. So 10 divided by 2 is 5. So square root of 10 over square root of 2 should be exactly the same as square root of 5. And again, type in the number now, square root of 5. Exactly the same. Yeah? So this isn't like magic. These aren't blind rules which you need to remember. You can double check these. You can literally double check these. So okay, let's do a few examples on this. So alright, square root of 16 over square root of 8. What do you think that is? Yeah, it's just going to be the top number divided by the bottom. Yeah, square root of 2. Hopefully that makes sense. Square root of 50 over square root of, let's say, 10. What do you think that's going to be? It's simple. One third with the top divided by bottom. 50 divided by 10 is 5. Square root of 5. Do this in the calculator. Do square root of 50. Is square root of 50 divided by square root of 10? Yeah, it's going to give you that. Now, just a little thing as well. Stuff which you shouldn't mess up as well. Yeah? So, for example, if I gave you this, yeah, that, don't fall into the trap of thinking that's this, because it isn't. Yeah, because this only works for two square roots dividing. That's not a square root, so you can't just all of a sudden join them. If you did want to join them, yeah, just for the sake of showing you, because I want you to get very logical about this. I want you to use your head. I don't want you to use these rules. When you use these rules, you know, you're always half worried. You're never fully confident because you're just following rules. This is how you get good at it. If you did want to join this into one, you know, surd, then you've got to first, remember this rule only works for a surd over a surd. This isn't a surd. But can you see that 2 we can write as square root of 4? You know square root of 4 is that. So you could do this if you wanted to. You see that? And then you could join that, I guess. You get square root of 2. So yeah, put that in. That. Yeah, so divide it. So stick that into the calculator. That'll give you a certain number. I bet you it's the same as square root of 2. So, yeah, pretty much that's that. So that's all there is to that rule. And for the same thing as well, you know, for this one, don't get confused by kind of, I don't know, doing this and thinking that this is 3 times 2 equals square root of 6. Just for the sake of it as well. Do 3 times square root of 2 in the calculator. I'll do that with you as well. That should give you like 4.2426, so on. And do the square root of 6. Yeah, it's like 2.449. So, you know, that doesn't work. Yeah, so that's one reason, you know. And it's because this little rule only works for 2 square roots multiplying. So, you know, don't mess that up. And again, if you did want to kind of join them together, then you've got to change that into a square root. You can change any whole number into square root. Because look, you know, the square root of 9 is equal to 3. So you could change this into square root of 9 times square root of 2, which gives you square root of 18. Okay. So that's if you want to join it into 1. But yeah, I mean, not saying you particularly need to, but you need to kind of be aware of the difference. So now, just a quick kind of thing as well. If you ever get two square roots multiplying together, which give you the same number, which are the same number, so like square root of 3 times square root of 3. What I'm trying to tell you is that will always, the answer is just going to be 3. And again, stick this into the calculator, do square root of 3 times square root of 3, that's going to be 3. There's a reason for this, because again, if you kind of join these together, you're going to get 3 times 3, which is going to give you square root of 9, which is 3. Now, there's a quicker way of doing this, because as soon as you get to that, imagine what that's saying. That's saying, I want a number, which if I multiply by itself gives me 3 times 3. Well, look at this. A number multiplied by the same number, 3 times 3, A has to be 3. Now, there's a reason, the reason I say this, because a lot of people, if I give them square root of 5 times square root of 5, they'll go to, that's equal to square root of 25, which is 5. And they never, for some reason, they never kind of like get comfy with knowing this little jump, that you don't always need to join this together. Now, the reason I tell you this is fine when you're doing it for these little small ones, but you might get a question which tells you square root of 24 times square root of 24. Now remember, surd questions are going to come up in non-calculator papers, because as you've seen with calculators, it's bloody easy, to do these questions, because they're just numbers. So here's the deal: if you want, you should be comfy knowing that square root of 24 times square root of 24 is 24. Because if not, this is what you'd have to do. You'd have no other choice. You would try join that together as 1. You do 24 times 24, which you'll either do by the grid method or long, multiplication, do all that kind of stuff. And you'll get to this point. You get to square root of 576. Now, whilst you guys can identify that square root of 9 is 3, square root of 25 is 5, and, for some of them, you're not going to, you guys don't know that this is, square root of 256 is 24. That's why you need to get comfy with this. Two square roots, which are the same, multiplying by themselves, are just the number without the square root. So let's just do a few more of these, but that should make sense to you. Here we go. So, what's the square root of 107 times the square root of 107? You betcha, it's 107. Square root of 83 times square root of 83. It's 83. Okay, simple as that. And then when you get to the point, square root of 7 times square root of 7, it's just 7. Right? You should be thinking that straight away. Get very, very comfortable. And similarly, by the way, don't forget, right? They'll stick algebra in there sometimes. Square root of 2x times square root of 2x. Oopsie. Is 2x. Square root of y times square root of y is y. Okay. That is that. So, right, so they're literally just the only two rules. But you can see there's a little bit going on with them. I guess that one, in a way, is like the third rule, if you want a third rule, but it's just this one working in the same way. So the next one is one not to fall into the trap of. Because sometimes, you ask someone, what's square root of 3 at square root of 5? They're like, oh, square root of 8? Question mark? No, it's not. And you can see why. Again, especially whilst you're revising, and you're not taking the actual test, and you have a calculator with you and stuff, get comfy checking this. So do this right now. Do the square root of 3 add square root of 5. What does that give you in the calculator thing? 3.9681, so on. And now do the square root of 8, which is 2.828, so on. See, this isn't a rule. This doesn't work. If it has two square roots and add them, there's no rule for that. You can't do it. You can't add two different square roots. Notice I said cannot add two different square roots. I'll be showing you in the next video when if you've got something like square root of 2 add square root of 2, that's going to equal 2 root 2. In the same way that x plus x equals 2x. Yeah? With this one, you've got to treat this as x plus y, because they're two different things. And, is there any way of simplifying x plus y? No, there isn't. It just has to stay like that. That's why this doesn't work. And the more and more I'm going to show you, surds just work like algebra, apart from these two rules. Yeah? Apart from those two rules. But this one, remember, that's not a rule. It's not a rule. A quick, actually, different way which you can know that. So here's if you're unsure, if I add them, would that work? So test two ones which you do know. So let's go for square root of 4, add square root of 5. Now we know that's 2, we know that's 5, so if we added them, the answer, it would be 7. We know this is 7. So here's what we do. Well, we say, we think that square root of a plus square root of b equals square root of a plus b. But you know what? Let's see this. Now, the square root of, square root of 4, if we, what am I talking about? So we're thinking that would be square root of 25 plus 4. Well, here's the deal. We know that's not 7. Because the square root of 49 is 7. So that's what a good way of, if you ever forget why that doesn't work, you just test it with two things you do know. A very, very smart way of going about your maths. If you ever forget a rule, you try it with numbers which you do know. Yeah, you make 100% sure. And if it doesn't work with, numbers which you do know the values to, it ain't going to work with anything else. That isn't a rule. So remember that very well. So, so 2 rules you got to know, and 2 rules you got to not know. Do you see what I mean? Now let me talk about breaking down big surds. This is a really, really big thing. So when they're in, obviously look, there are some surds, which you want to be very interested about. Think of a better way of saying that later. And it's a square number one. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 5, what am I talking about? Square root of 25. Let me clean that up for you. It's 5. Square root of 36 is 6. These numbers you want to almost always have in your head. Because here's the deal. Sometimes, if in a question, in any question with surds, if you get a sort of big surd, which kind of breaks down to 2 other numbers, I'll tell you what I mean in a sec. I want you to do this. You've got to get comfy breaking down big surds. So for example, let's look at something like square root of 50. Yeah? If they ever give you square root of 50 in any question, you should be changing that immediately. You don't want big surds. And big surds can mean anything. I'll show you why square root of 8 is a big surd. It's not just a number. It's this. Can you see that the square root... Let's think of... What we're going to do is we're going to break it down to 2 smaller surds. So let's think of a few ways which 2 numbers could multiply to give us 50. So, 2 and 25 is one. So 25 and 2. We could have 5 and 10, I guess. And that's it. Okay? So can you see there's 2 different ways of breaking down square root of 50. And you know what? Just check it as well. Put square root of 50 into the calculator. See what that comes out to. What does that come out to? We did this before. Like 7.07. So yeah, 7.07107. Okay? This is exactly the same. This is exactly the same. That's because it's rule works. But here's the deal. What if I told you one of these is a much better way of breaking it down? Have a think. Which one do I prefer? Alright? And I'll tell you this. It's this one. The first one. And there's a reason for this. The reason is simple. Because I know that root 25 is just 5. So can you see that? I can literally, this will turn into 5 times square root of 2, which is just 5 root 2. Why is that, by the way? You know, the same reason that 3 times x, we write 3x. Exactly the same reason. 5 times root 2, we write 5 root 2. Does that make sense? Same reason. If I can show you with, I'll put right underneath 5 times x, you see? That would equal 5x. So that's why, if you see something like this, so if you see something like this, yeah, 10 root 3, that literally just means 10 times root 3. Okay, hopefully that makes sense. So, this is what I want you to get comfy with, breaking down these big surds. Very important, very, very important. Why? Because a lot of times they'll give you a question like this. Square root of 50, add, let me get this right in my head, square root of 18. Now, you would think at first glance you can't add these. So they might say, like, simplify. But here's the deal. You know, so you could break this down to 5 root 2. Now guys, try break down root 18. Okay, take a second, try to do that yourself. So again, this is how you do it. You just think of two numbers, which it breaks down to. So it's square root of 2, square root of 9. Yeah? And remember, I don't think there's another way. There's obviously square root of 1 and square root of 18, which is pointless. That'll just become 1. So you're just saying it's square root of 18. So don't do 1 as a thing, but this one only has that. Now look, square root of 9 equals 3. So can you see this actually ends up becoming square root of 2 times 3 equals 3 root 2. So check that out, you know. You can literally transform these things. And in the next video, just keep that in mind as well. So at first glance, where you're like, oh, these are two big surds which are different. I can't add those. That's a trick question. You can, because sometimes they break down to smaller surds like this. Yeah, and you'll see later that equals 8 root 2. But for the time being, let's just practice breaking down a few more surds. Simple as that. So, right, let's pick root 75. So let's think of a few different ways this will break down. So I know 5 goes into it, so I guess we can break it down to 5 root 15. That's one possible way. What's another way? We could do 3 root 25. Is there any other way? Not that I can think of. So guys, which of those do I prefer? Literally the second one. Again, the only reason is, remember, square root of 5 is going to be some ugly number. Only these break down to nice numbers. Only these. Only rational surds. Yeah, so I don't know what any of these are, but this one I do know. This is 5, so this will become square root of 3 times 5, which is 5 root 3. See that? So let's think of another one. Let's break down square root of 8. Yeah, this one should be straightforward. This one, all you're doing, you're trying to think of any two numbers. But after you get good at this, and there are a few possible ways, you're just, in a way, you're almost like kind of going through this is the way you should be going for root 75. You're like, can I divide it by 4? No. Can I divide by 9? No. 16? No. 25? Yes. Alright? And you just break it down. But anyway, this one, we know this equals 2. So can you see it's just going to be 2 root 2. Now, so that's literally it. If there's a big surd in any question, I don't care. Listen, if they give you a question like this, yeah, the first thing before you even worry about this, every big surd which you know you can break down, by break down I mean one of these surds can be used to split this up, do that. Every single question. Any question which gives you a big surd, break it down. I don't care what the question is, I don't care what it's asking. Always break it down. Maybe just do a few more things I'm trying to think of off the top of my head. Here we go. Square root of 400. Now this is an interesting one actually. So here's the thing. So you could be like, 4 divides that. Actually, yeah, that does. That's straight away obvious. Okay, actually that's a rubbish example. Okay, but can you see square root of 4 is 2, well, you know what, could have wrote this down into what? Also 8 and 50. What else could we have wrote this down to? 40 and 10. Any other ways? Yeah, probably 25. And was it like 16 or something? Yeah, that would work. Yeah, a few other ways. The best ones here are these two, root 8 and root 50, don't break down. These two don't break down to either something we know. But these, funny enough, both of these do. So square root of 4 is 2, square root 100 is 10. So the answer is 20. Also, this would have been perfectly good as well. This would give me 5, this would have been 4. So that's 20. And that's it. It's not that these are wrong, it's just that these get us to what we need to do much quicker. And that's it. Okay, that's it. Yeah, you know, go through maybe a few more examples, but you see loads of examples anyway when I go through a lot of exam questions. But yeah, for the time being, that is that, guys. Right? And now in the next video, I'll tell you the only time you can add two surds together. The only time. Right? See you in the next video.